Good afternoon, students. In the previous class, we have seen molecular orbital theory, diagrammatic representation of B2 molecule. Up to B2 molecule we have seen. Now we will continue that one. Before that, I think everyone you understood what is the diagrammatic representation as well as what is the electronic configuration according to molecular orbital diagrams. Molecular orbitals. Molecular orbitals, they will follow electronic configuration for two types. Less than or equal to 14 electron system, one type of electronic configuration is there. Greater than 14 electron system, another type of electronic configuration is there. Students who are writing these configurations of N2O2, which I gave homework in the last days, okay, just observe oxygen O2 molecule is greater than 14 electron system, that is contained by 16 electrons. So second electronic configuration we need to follow. That one also now I will explain. Before that, up to B2 molecule we have seen. Now we will start with next molecule, that is C2 molecule. Okay, I hope you are very clear about the concepts which we have completed. Now let us see how to write the diagrammatic representation of this C2 molecule. C2 molecule contains two carbon atoms, in which each carbon contains 6 electrons. Okay, then total number of electrons present in the C2 molecule is 12 electrons, and the system is called 12 electron system. And the system is called 12 electron system. Now, this is less than 14 electrons only. 12 electrons means less than 14 electrons only. Okay, now let us write what about the electronic configuration of each carbon. Carbon electronic configuration is 1s2, 2s2, 2p2. Same, another carbon also 1s2, 2s2, 2p2. Okay, now we are going to show what about the molecular orbital diagrammatic representation. Left side arrow mark representing energy, below to above energy increases. Okay, in previous class also I told whatever the thing I am writing here, this one must be written here. Means energy increases like that we have to show. Okay ma? Now let us see. First, between 1s and 1s. This 1s and 1s will undergo constructive interference as well as destructive interference. Okay. If they undergo constructive interference, they will be formed as molecular orbital, bonding molecular orbital, that is sigma 1s. If they undergo destructive interference, they will be formed as sigma star 1s. In 1s, how many electrons we have? 2 electrons here also. So totally 4 electrons are there. Okay, those 4 electrons will be following like this. This is about 1s and 1s. Next coming to 2s. Okay, see. This is sigma star 2s. This is sigma 2s. These are 2s orbitals. Total 4 again. Like this. 1s, 2s. Diagrammatic representations. Okay. Now coming to 2p. Okay, ma? These are all well known. Already so many times we have drawn. Next, coming to 2p. P has 3 orbitals, 2px, 2py, 2pz, one electron each here, like this. Now they will undergo constructor interference to form two orbitals here. Those are pi 2px, pi 2py. We are following the electronic configuration less than 14 electron system now. Okay, next. This is one orbital, sigma 2pz. Next, two orbitals, pi star 2px, pi star 2py. Finally, one orbital, that is sigma star 2pz. This is sigma star 2pz. These are pi star 2px, pi star 2py. Sigma 2pz, pi 2px, pi 2py. Okay, now totally how many electrons we have? 4 electrons. That 4 electrons, they will be filled 1, 2 by following Moore's rule. Third electron will be entering here, fourth electron will be entering here. So no electrons are present in sigma 2pz. No electrons are present in sigma 2pz. For C2 molecule, this is the diagrammatic representation. Now we are going to show electronic configuration. That electronic configuration is, I will write that one now. Before that, observe this diagram all of you. Here I am going to write electronic configuration. Sigma 1s2, sigma star 1s2, next sigma 2s2, sigma star 2s2, next pi 2px2, pi 2py2. That is the electronic configuration of C2 molecule. This is diagrammatic representation. Okay, now I am going to rub this one. Before that, please all of you observe this one carefully. This one is following less than or equal to 14 electron system. So first we will get pi 2px, pi 2py, then sigma 2pz. If it is greater than 14 electron system, this sigma 2pz will be here, pi 2px, pi 2py will be here. Though that is only interchange will be happening. Okay, next. By using these molecular orbitals, we have to find the bond order. Electrons present in the molecular orbitals, we have to find the bond order. Bond order is equal to NB minus Na by 2. What is meant by NB? Number of electrons present in bonding molecular orbitals. 1, here 2 more, 2, 4, 6, 8. NB is equal to 8. Na, number of electrons present in anti-bonding molecular orbitals. 4. 8 minus 4 divided by 2 is equal to 4 by 2 is equal to 2. This is the bond order. Bond order 2 means molecule will be stable. So molecule exists. And while we are writing the electronic configuration or diagrammatic representation, did we see any unpaired electron? No unpaired electron is present. So C2 molecule is diamagnetic. C2 molecule is diamagnetic. This is the information about C2 molecule. Na? Up to carbon we have seen. Next we have to see N2 molecule. After that O2. Up to O2 we will see, and regarding O2 we will talk about later. Okay, now let us see what about N2 molecule. In the same way, N2 molecule contains 14 electrons because each N atom contains 7 electrons. No? In that way it contains totally 14 electrons. So this is called 14 electron system. Electronic configuration of nitrogen is 1s2, 2s2, 2p3. Another nitrogen atom 1s2, 2s2, 2p3. First, 1s and 1s will undergo molecular orbital diagrammatic representation. So we will show sigma 1s, sigma star 1s. 2 electrons will be here, 2 electrons will be here. Next, 2s, 2s. Same, 4 electrons here, 4 electrons, then like this. So 2s, 2s completed. Okay, next, here 2p, next coming with 2p. This is contained by 14 electrons now. Less than or equal to 14 electron system. That configuration we have to follow. Okay, now 2p contains 3 orbitals. 2px, 2py, 2pz, same way. 1 electron each. First, two orbitals, no? Those are pi 2px, pi 2py. 1 orbital here, that is sigma 2pz. Next, 2 orbitals here, pi star 2px, pi star 2py. Finally, 1 orbital here, that is sigma star 2pz. Totally, how many electrons are present? 6 electrons. That 6 electrons must be entering into molecular orbitals by following Hund's rule first. 1, 2, 3, 4, 5, 6. Sigma 2pz contains 2 electrons. Okay, this is totally diagrammatic representation, and this one must be represented. Left side, arrow mark energy. Okay, ma? Now, what is the electronic configuration? Electronic configuration is sigma 2p, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Next, pi 2px2, pi 2py2, sigma 2pz2. This is the electronic configuration of N2 molecule. What about bond order? Bond order is equal to Nb minus Na. Number of electrons present in bonding molecular orbitals. 1, here 2 2 to 4 to 8, sorry 6 to 8, 8 to 10, 10 minus 4, antibonding molecular orbital electrons 4 divided by 2, 6 by 2, 3. So what is the bond order for N2 molecule? 3. Molecule exists. That's why N2 molecule we know, N2 gas. Okay, and coming to this magnetic nature, this is diamagnetic in nature. This is about complete information regarding N2 molecule. Okay, ma? Now we will see what about O2 molecule. Final one. O2 molecule is 16 electron system. Electronic configuration is 1s2 2s2 2p4. Here also 2p4. This is oxygen. Now we will see sigma first 2 2 like this, correct only. Next 2s 2s. This is also okay. Okay. Now 2p4 2p4. How many electrons are there? 4 electrons here. Here also 4 electrons. Totally 8 electrons. But the thing is, we have to interchange this one because this is greater than 14 electron system. Na? We have to follow the electronic configuration which is for greater than 14 electrons because O2 contains 16 electrons. That's why we need to change this, interchange this one. Then we have 2 orbitals here and here we have 1 orbital. This is sigma 2pz, this is pi 2px, pi 2py. This is pi 2px, this is pi 2py. Okay, total number of electrons present 4 plus 4, 8 electrons, na? 1, 2. Next 3, 4, 5, 6. Next 7, 8. Here it should follow Ohm's rule. That's why 1 electron enters first singly. 1 electron enters singly. After that only pairing will be taking place. But here it has 16 electrons only, na? So 1 more electron is not there. It has 2 unpaired electrons. Okay. Now what is electronic configuration? Sigma 1s2, next sigma star 1s2, sigma 2s2, sigma star 2s2. After that sigma 2pz2, pi 2px2, pi 2py2, pi star 2px1, pi star 2py1. This is the electronic configuration of O2 molecule and this is electronic representation, diagrammatic representation. Please draw these orbitals here. So many times I told in your book. From below to above, like that energy will be increased. As it is not possible to draw on board, I am drawing right side. Please understand that, all of you. Okay, please draw this right side portion here. That one. Now coming to this bond order, O2 molecule bond order, let us see. I am going to rub this one now. Bond order is equal to Nb minus Na by 2, number of electrons present in bonding molecular orbitals. Let us see what about that one. Two, 4, 6, 8, 10. 10 bonding orbital, 10 electrons present in bonding molecular orbitals minus 2, 2, 4, 5, 6. 6 electrons present in anti-bonding molecular orbitals divided by 2, 4 by 2, 2. Oxygen molecule exists. But while we are drawing the diagram itself, we have observed that 2 unpaired electrons are present. Even here also we can see 1 electron. So oxygen molecule is paramagnetic. Valence bond theory, hybridization, no model explain the paramagnetic nature of O2. But practically O2 is paramagnetic. Okay, suppose when we inhale the gas, air, only oxygen will not go inside. Along with oxygen, other gases also will go. But why oxygen only it is getting towards lungs and remaining gases they will be exhaled out because of this slight magnetic nature. Lungs contain small organs which are used for exchange of oxygen. Those are slight magnetic in nature. So they will attract the oxygen. Remaining gases will be expelled. Okay, so oxygen gas only it is getting attracted towards lungs. Not only this one, practically by doing this experiment also, magnetic susceptibility values, scientists found that O2 is paramagnetic in nature. But till now, what are the theories we have seen? All the theories, no one has explained that O2 is paramagnetic. We will come to know that O2 is diamagnetic only. But this is the theory which explains O2 is paramagnetic. This is the thing, difference of hybridization, VSEPR theory and molecular orbital theory. Okay, by this, every magnetic nature, molecular stability, all are explained by using the molecular orbital theory. Okay, after this some points are there. This one, till this we completed the molecules. Okay, O2 molecules enough, up to O2 it is enough. Even in your textbook also up to O2 only they give. It is enough for us. Okay, and I hope you understood everything whatever we wrote. Okay, now we will see some important points present in this molecular orbital theory. Okay, ma? See. First, bond order is treated as number of bonds present between the atoms. Bond order is treated as number of bonds present between the atoms. Suppose O2 molecule bond order is equal to 2. Normally we have seen O2 molecule bond order is equal to 2. We have double bond in oxygen molecule. N2 bond order is equal to 3. Then we have N triple bond N. Like that we will say, by using the bond order we can say number of bonds present in the molecule. If bond order is equal to 1, 1 bond is present. If bond order is equal to 2, 2 bonds are present. If bond order is equal to 3, 3 bonds are present. Like that we can say. Okay, this is first point. What is the first point again? Bond order is treated as number of bonds present between the atoms. Okay, next, second one. When bond order increases, number of bonds between two atoms increases and stability of the molecule also increases. Once read the point, all of you. When bond order increases, number of bonds between two atoms increases, and stability of the molecule also increases. Let us see. O2 bond order 2, N2 bond order 3, O2 bond order 2, N2 bond order 3. Out of these two molecules, which molecule is more stable? Out of these two molecules, which molecule is more stable? Why? It has more number of bonds. See, when bond order increases, number of bonds between two atoms increases, and stability of the molecule also increases. When number of bonds are increased, we cannot break them easily. Then molecule is highly stable. Just observe the points now carefully, all of you. First one, BO is treated, bond order is treated as number of bonds present between the atoms. Okay. Next, second point, when bond order increases, number of bonds between two atoms increases, and stability of the molecule also increases. Okay. So by using this bond order value, we can say the stability of the molecule easily. The molecule which has higher bond order will be highly stable. The molecule which has higher bond order will be highly stable. The molecule which has least bond order will be least stable. Like that we can say. Okay. Next. Third point. When bond order increases, bond length decreases and bond energy increases. We don't know what is this bond length and what is this bond energy. Is it okay? Now let us see. Suppose O double bond O, N triple bond N. Okay. Distance between these two atoms is called bond length. Distance between these two nitrogen atoms is also bond length of nitrogen. This is the bond length of oxygen. Now in oxygen, how many bonds we have? 2 bonds. In nitrogen, 3 bonds are there. 3 bonds means strong attraction will be there between N and N. 3 bonds means strong holding will be there. Then N and N will be closer because of the bond length decreases. When more number of bonds are there, strong attraction will be present between two atoms. Then what will be happen? They will be coming closer. When they come closer, length decreases. Distance between the atoms decreases. Are you clear now? Now, when bond order increases, 2, 3, number of bonds increases. When number of bonds are increased, bond length decreases. That only I told. Bond length decreases. When bond length decreases, the atoms come closer. Attraction will be strong. We cannot break the bond easily. We need high amount of energy. That is called bond energy. The amount of energy required to break the bond is called bond energy. The amount of energy required to break the bond is called bond energy. Particularly, what is the definition of bond length, bond energy, all these things in bond parameters we will see. We are remained with 2 more topics now. Bond parameters, hydrogen bond. By that, chemical bond chapter is going to be completed. Okay, in that bond parameters, we have bond angle, bond length, bond energy, all these things. At that time, correctly what is the definition also we will see. But now, what about this statement? When bond order increases, bond length decreases and bond energy increases. What is the meaning of this one? When bond order increases, number of bonds present between the atoms increases. When number of bonds present between the atoms are increased, they are nearer by each other. Attraction is strong. We cannot break the bond easily. Bond length decreases. We cannot break the bond easily. Then bond energy increases. I hope you are clear. They will give, okay. In NEET, there is a chance to ask this type of questions. In NEET, they will give 4 options. Okay, different molecules they will give. They will ask which of the following molecules have highest bond energy. They will not ask the value of bond energy. Which of the following 4 options, molecule which has high bond energy we have to show. Molecule which has high bond energy, it should contain high bond order. When bond order is more, okay, more number of bonds are present between the atoms, then easily we cannot break the bond. It requires high amount of energy, leads to bond energy increases. So we have to check the 4 molecules which contain high bond order. Okay, according to that we can say what about the bond energy. Like that there is a chance to get asked with bond length also. Okay, but every time remember this point, when bond order increases, bond length decreases and bond energy increases. Okay, out of O2 molecule and N2 molecule, bond energy is more for N2. That's why N2 cannot involve in bonds easily. In kurkure packets, Lay's packets are there. Okay, that is not actually that kurkure is food material. No? Kurkure packet or Lay's packets, whatever, those are food materials. Okay, if they are allowed to expose to air, oxygen, they will undergo reaction, decomposition. So no longer that food material is preserved. Then what we have to do? The company will take care that food material should not be spoiled, because it should be kept in shops so many days. We are going to buy that one. When we are not supposed to buy, it should be longer preservative, correct or not? That's why what they are going to do, those packets are filled with N2 gas. They can fill with inert gas also, because inert gas also they won't react. But here the problem is inert gas are very less amount present in the atmosphere. They are highly expensive. That's why what is the other one alternative? That is N2 gas. N2 gas is filled into that kurkure packets and that Lay's packets. Then what will be happen? Inside oxygen gas will not be there. Because of this N2 gas, oxygen gas is not available. Then the food will not undergo decomposition. Because of that, food will be long lasting. At once if you open that packet, oxygen gas will enter. It is exposed to air, so oxygen gas will enter. That's why immediately after opening that packet, we have to complete that one. We should not preserve like in shops whatever they are keeping. Because oxygen gas, at once it is entered, it will undergo reaction easily. So it will decompose the food material. That's why N2 is more stable. As it is stable only, inside if it is there also, it is not undergoing reaction with food material. This is preserved. So this is preferred. Okay, ma'am? This is about 3 points present in molecular orbital theory. Third one, when bond order increases, bond length decreases and bond energy increases. Okay, ma'am? By using these 3 points, some questions might be cleared by NEET students. That is the thing. Okay. I hope you understood this today's class, all of you, everyone. We have seen totally 8 molecules. Started with hydrogen, ended with oxygen molecule. What is the magnetic nature? How they are stable? Whether the molecule is existed or not? By using bond order. Okay. Depending on bond order, after that we mentioned 3 points. Those 3 points are highly important. Please refer them once again. Okay. When the length decreases, the molecules are coming closer and the molecule is more stable. Bond energy increases. Bond length and bond energy are inversely proportional to each other. Okay, ma'am? This is about today's class. I hope you understood. By this we completed molecular orbital theory. Next, 2 more classes we will take to complete 2 concepts. Those are bond parameters and hydrogen bond. By 2 more classes we will complete this chemical bond. After that we will start with organic chemistry. Okay, ma'am? Thank you. Have a nice day. Thank you all once again.